we're testing out a YouTube stream. So let's see. I don't know, are we live? We need to check that. It says there's no current live. There's no current stream. Select the stream. We should try refreshing. Oh yeah, I think we're live. Okay, so we are live on YouTube. Yep. Okay. I was thinking it was gonna take um the name of the stream that we selected. Okay. But anyway, we're live on YouTube. Um, how I think I would need to be able to, let's see. Yeah, I want to get the link. Okay. Yep. Stream URL copied. So just a second, like this is the first it's a would I say the test stream on YouTube? Let's see. Just getting things started here. All right. Used to stream on Twitch until yesterday. Yeah, I want to see how YouTube I think I tried YouTube once. Just wanted to see. Yeah, but yeah, indeed we're live there. All right. So that's cool. Okay. Um so I'm just gonna share the live link right now and then let's get to it. Um, okay. All right. Mm, okay. So I'll just share the link out. And I don't know. I think there are a couple of people who expect me to stream on Twitch this morning. They are gonna miss this. Okay, I'm just gonna try to share the link to them and let's see. Mhm. Okay. All right. So let's get to it. Um. Yeah. I think I have one more place to share this. Let's see. We'll start in a bit. Yeah. Uh. I'm just sharing the live link, and then let's see. I mean, like I said, we're testing out streaming here. Yep. Okay. So I think even the OBS software. looks pretty okay. It also has like a studio where I can see stuff. Okay, not bad, not bad. I think that's okay. It's just that also, no, I think it's okay. I can also even like see chats and stuff. Yeah, so that's fine. Um, yep, yep. Okay, so let's start. Um, yep, let's get to it. Started. Wait, hold on. Okay, so let's do this. Let's get to it. So, as I said, this is the first. Well, not first, actually, second. So I had one trial stream on YouTube, but now let's do an actual stream today. And supposed to do it on Twitch. But let's see. So let's get to it. Previously, we were learning. We were doing. It's Rustlings, right? So I mean, the Rust programming language is what I'm referring to. So there's this program where so Rust has a book. The Rust book. This is the Rust book that we were seeing earlier, and there is this accompanying program, right, called Rustlings, where there are exercises and you basically solve them, right? So you learn the language, you learn the concepts, and then the program has like has exercises with sometimes with bugs in them or to-dos tasks you have to do. So we use this as an accompaniment to the book, yeah. And we are on the exercise on error handling and error handling, and we have so basically error handling in the Rust in the Rustlings, yes. There are a couple of things that we have to like do, there are a couple of further reading, like recommended reading for you to solve error handling. And the last one of it is box and errors, and that's this one here actually. And by the way, this one is not in the Rust book. This is actually the Rust language reference. So there's it's sort of like a documentation or helper docs that was provided by the team that designed the language, and this is it. This is the Rust language reference, and the section is blocks and arrows, which we've done, like we've done that previously. If you were following on Twitch, you would know that we were doing that there. Um, yeah, um, and we want to I mean boxing arrows we did that. I think we left off at yeah, we've also did wrapping arrows. So again, also so I think the videos are still on Twitch because they were done like in the last 7 days, yes. And the last one here is, so the last section on error handling is iterating over errors, right? So I think I want to do this, and then we start to solve the Rustlings exercises, yeah. I mean, that's my idea here. Can also let me know. So yeah, iterating over errors. We will go through this and like check how the we try to write the code. Like yeah. So to iterate over results, not errors. Sorry, over results. But it's on the error handling. Yes, okay. Because like so for error handling in Rust, you use basically the option enum or the result enum, which if it's the option enumeration, um you have the sum or the none, and if it's the result, you have the okay or the error, right? So I'm referring to Rust standard library, and I'm referring to the option enum here, where you have like none and some, which helps you to deal with the concept of something not being available, yeah, or the result type, result enum as well, right? Where you have the okay or error. So you can deal with errors mostly using these two, or like you can also mostly the result actually, because the result is explicit. You can have error and also the error can contain a type, yeah. And so having said that, let's now see this section. So iterating over results, an iter map operation might fail. So basically, okay, an iter map operation might fail. So basically, what's happening here is that we have a wait, I think I need to close this. Yep. So what's happening here is that um, we have a vector of strings, and we we have a vector of string values. Yeah, there's string values, including this one, or string literals, you want to call it. And we then declare binding numbers, and we say the type is, we don't care about the type unknown. And then what, we take the strings and we do into iter. So basically, we convert the vector into an iterable, and we want to map over it. Okay. And then for each item, we want to try to convert that to the ith32 type using parse with the turbo fish operator here. And when we're done, we call collect. And collect will try to convert this to the type, the destination type, or the target type here. Yeah. And this is a vector of unknown type here, or yeah. And then what? And then we want to print the result. So it might fail, they say. Um, let's see. I have a program that I was yeah, let's use this program. I think this is the previous program we had. I don't need everything here. Scared of everything. Um okay, yeah, this is talking about boxing error. I think I need error. Yeah, I want error, but let's see. Is there not necessary? I think I don't need any of these ones. This is also, I don't need this, yeah. So oh yeah, okay. And then let's get rid of this as well. So this is from like previous previous code where I was writing, I think yesterday also. Yeah. Okay. Yeah, it's complaining because the main function doesn't return anything, right? So we will write out the code here, and this is just so basically main function can either return like the unit type, right, or it can return something like this. I'm also fine to say, okay, so we can do here, we can just say return okay, yeah, and unit type, and this would be fine. Yep. So we have an empty main function. Let's write the code. What we were doing, we said let I think they had a vector, they called it string, and it was a vector. There's the macro, and they said it was like a couple of things. Um, whatever. They have a vector, and they were converting the vector to I don't know, some, and they were doing strings dot into iter, which creates an iterator from a value. Okay, so let's look at the documentation for this. It would into iter, it just gets you an iterator, and then you can call next on it, or you can do whatever else. So into iter, and then we can do a couple of things. We can map. We have some functions and functions on it on the iterator. I think we can even see that. So basically iterator. So if we have an iterator, this is a standard trait um, for the iterator. And we have next, which gives you an option, yeah, of an item, yeah, that has an item of that type, advances it, of course. into iter and next, yes. And you also have what next chunk? Let I think we're looking a bit off. Yeah, okay. It's better. I want to see the methods that we have on it. We have chain, we have collect. I think, yeah. So collect, when you provide a type, it would um it would collect it into the type. That's the word I should say, yeah. Yeah. Okay. Collect can take anything iterable and turn it into relevant collection. Okay. We also have there's a collect into. How does that one work? Oh yeah, you provide the collection that it should collect into. Makes sense. You have a filter that takes a predicate. How that works is like so. Makes sense. Okay, flattening and fold. So yeah, I mean, the Iterator is really powerful. It has a lot of cool stuff there. I mean, that you can do. Then there's also map. Map takes a function in this case, or I mean, a closure, you can call it, yeah, and creates an iterator which calls the closure on each element. Yes. Yeah. Yep. That's it. So it says that if you're good at thinking in types, you can think of map like this. If you have an iterator that gives you elements of some type A, and you want an iterator of some type B, you use map. Passing the closure that takes A and turns it into B. Yeah, map is conceptually similar to for loop, yes. However, a map is lazy. Uh, so I think, okay, it's best to use it when you're already working with other iterators. If you're doing some sort of looping for a side effect, it's more considered idiomatic to use the for loop. So this means lazy, which means that a map would not fire until you call the terminal operation, right? Like collect on it. Is that what that would mean here? Lazy evaluated. I believe that's how it would work in other languages, right? Um, okay, so that's fine. We saw what we wanted to see. It's so yeah, you have into iter and then you try to map this and you say take an element here. We already had S, yeah. Take an element here which is a reference to a string slice that has a static lifetime, whatever. And then you do you try to parse this, and we want this to be of a type. Yeah. Okay, I think this is what they were saying, that this can scroll. So that's what they were saying about handling the errors here. And then we wanted to collect this. I think that's what we wanted to do. We wanted to collect this. Yeah, and this is gonna give you type annotations needed. So it doesn't know how to convert this. It doesn't know what type we should convert this to. We can collect this. We can do that here. Uh, I think it should be like so, right? Um, will this work? Um, but you can collect. You can wait. We saw that, right? For an iterator, when you want to collect, um, yeah. Okay. Okay, that's not you'd. Yeah, exactly. That's what we need. Okay, so you have to say the type of full. Okay, so that would be us doing it. Like, wait, let me move this around here a bit. That would be us specifying. We have to specify the full type, not just the type of the inner type. So we would have to say is a vector of um, any type. This is still complaining about what? The vector of results. Mm, okay, I think that is hmm, okay. I think that's it. Interesting. I mean, yeah, we know we can do this, but I think the example they had was like I think it wasn't result. So okay, but wait, what if I do so as you see here, the type is a vector that has result and it's a vector that has result of type I32 and parsing error. I mean, it can be that or parsing error. Um, but what if we had this instead? Like, what if we don't have result here? I mean, what if we don't have the type we want to collect into here, but instead we say, and that's completely yes. I think what it had there was like vector of any type. This would also work. Ah, yes. Okay. So again, oh yeah, this makes sense. Yeah. So because like the parse returns a result. Yeah. A result that has of course okay and error, right? Or error and when you collect, you're collecting the what is returned from parse, right? So which is the result there. Yeah. Okay, that makes sense. But now you say this is any here, but I think I prefer what we had before. This is much better. Yeah. You specify the type. And then they say this can give you errors. Of course, we know that it can give you errors. I think that's what we saw here. So you want to print results, and then you would have. So now we're looking at how do we iterate over the errors. Okay, so let's print this and see. I don't know. So this will be. Wait. Yeah, of course, the first one fails. Even the first one. Yeah, so you have the errors here. You have a result. You have a there's a vector of results. So you have error. First one, an error that has a parsing error that has kind invalid digits. The second one is an OK. This is a result vector that has these that has an error that has an OK, an OK, sorry, and has an error. Yeah, okay, that's what we expect. Yes. So now saying so how do you ignore the failed items with filter map? How do you ignore the failed items with filter map? 1 second, I need to um send this. Yeah, just a second. Uh, okay, yep. So, how do you ignore the failed items with filter map? Um, okay, so it's just so you have yeah, filter map will take a predicate, I believe. Yeah, that's what it should take because if you're doing filter will take a predicate, so filter map would take a closure. Yeah, they also have the predicate. How does that work? Let's see what's the standard definition of that. Um, filter takes a predicate, yes, but filter map takes a closure. that returns a filter map of, so this creates an iterator that both filters and maps. Okay, the return iterator, and we want to return the, okay, iterator. The return iterator yields only the values for which the supply closure returns some value. Okay, okay, now that makes sense. Okay, um, the, the return iterator yields only values for which the supply iterator returns some value. Oh, because it returns an op. No, no, it doesn't return an option because it's like, okay, no, it's the where. So like where f, which is the closure, is a function that returns an option of a certain type C of the an option of the type that you put in the filter map, which is in this case um odd. Okay. Okay, so filter map can be used to can be used to make chains of filter and map more concise. So you don't have to do filter and then map. Yeah. Okay. So in this example below, we see how a map dot filter dot map okay can be shortened into filter map. So basically is that you have like these, and then you get an iterator, and then you call filter map, and it like it does like, okay, so you parse it and then say okay. So this returns us a result, and then we say okay. Okay converts a result to an option that we know of, yeah. And yeah, so it has to be f returns you an option, where f the trade where it's not a trade bound. Oh, where f is of, okay, and it returns the entire thing returns you an option. But how does it work when you have like you have a result and then you convert the result to an option? Well, we just need a closure here. It's a bit weird. So I mean, I want to write this and see exactly what how that makes sense. Um, so basically we can say I want to write that and see how that is. So what do you have? You have um use a vector macro that has like whatever, and then we're doing a dot iter. I think you have to get an iterator, and then you do a filter map. Yeah, filter map, which as we saw, it takes create an iterator of both filters and maps. The return iterator yields only the values for which is supplied closure returns some value. So this takes a closure, sorry, takes a closure, and I can say V, for example, which is string slice, I refers to string slice, and then I'm gonna try to parse this. And no, wait, hold on. About filter then. Oh yeah, sorry, it's not A, it's B, that's what we have. Yeah, we can parse this, and then wait, hold on, I wanna see. Yeah, mismatch types expected enum option. Yeah, so okay, so it expects a enum. Yeah, because that's how it would give you only that's how it would do the filtering and only give you the ones that have a sum. But this is very okay. Well, if you wanted to specify how it should filter, then you use a predicate, right? Then you use the filter itself. So this needs to take in an option. I think that is what was not clear from here. It just says, oh, yeah, it's clear. Just that, okay. So you have a filter map over a generic B and F, which is closure, whatever. Here F, where F is a mutable function um, from self and integer items uh, in this type here that has to be able to produce an option of this type. So it give us an option of the type we're passing, which is I32 in this case. Okay, that's what. Okay, okay, that makes sense. So yeah, we will then convert this to we do okay, which converts the results to an option, and that would be fine for this. Yeah, these are just warnings that it's it's useless. But let's try it out. Come on. Yeah, okay. So that's how the filter map would work. Fine. But if we wanted this to be a filter, we would say like actually if we wanted to do this as a filter, we can say that filter, which could an iterator which uses a closure to determine which element should be yielded. Um, this would take the predicate. Yeah, this is it here. And then it returns filter that has a predicate. So if we say a predicate, so this will try to parse this. Um, if we wanted this to be or let's even say that not even parse. Let's say we have a vector of numbers. And I'm just trying to see how the difference between these operations or these operators here. So let's say we have that and the vector of numbers, and I wanted to do so we wouldn't do parse here, but instead I want a predicate here. I can say each of these where um so what? So you do a filter. Oh yeah, it's something about like this, right? Uh, what is your? Oh wait, cannot calculate cannot calculate. So does this need to? Maybe we need to dereference this. Yeah, okay, that's fine. So but it says filter that must be used uh are lazy and do not do anything. Is that it? So this filter would not be used. Let's see if we had a filter here. This is positive. So it's lazy. Okay, and this is how filter would work, which makes sense. But the question is, yeah, it's lazy, so it wouldn't print anything. Yeah, I think so. Let's try. I think we don't. I think this wouldn't print anything. Let me. Let's keep this code. We'll come back to it. Wait, why? Okay, yeah. Okay, we'll come back to that code in a bit. Let's. Uh, mm, yeah, it's just an iterator. Exactly, it's just an iterator. Of course, you cannot print an iterator, right? So you can't do anything. I'm just curious, right? So let's see. I'll see the error we get. Oh yeah, we can actually. So it actually prints the iterator for us. It prints the entire thing for us. It prints the entire values of the iterator for us. So like it's um yeah, prints everything for us. However, mm, um okay. So if we did say the next value of the iterator, what is that? Cannot mutate immutable variable y. Oh, next is going to mutate this. Start it on the. Why would next mutate the iterator? Is next? This is we are on iterator. Okay, next. Advances the iterator to the next value. Returns none when iteration is finished. Okay, yeah, that's an option that returns. When you call next. Oh, okay. So next takes a mutable reference to self. So that has to be mutable. Interesting. So that's how it would work. Okay. Okay. So this has to be mutable. That's what it means. And we should be, wait, what? Um, what's the issue here? We can do that, yeah. Or not? What's it? Variable doesn't need to what? Let's see. We have an error. Could not compile. Yeah, that looks strange. I think the position of our. Oh no, it's not this that needs to be mutable. We put it. It's not supposed to be. I mean, A is fine. It's just a vector. But then this is what needs to be mutable. Well, why does it? Why does it complain about that? That's strange. I think we have some. I think this program is not being correctly. I mean, I don't get any support here on mute. Mute is supposed to be highlighted, but anyway, that's a different thing. Um, so we have, uh, yeah, exactly. So now we see that the next value is sum two here, which is what we expect, where the value is an even number. But when we're printing this previously, it was giving us the entire values we had in the iterator. So that's lazy evaluated. So you need a terminal operator which is in this case next, to evaluate filter. And I think it's going to be the same thing with map. When you have an iterator and you do a map, and you say map is going to just be a closure where we want to go from one type to another. So it would be where you want to map I to I plus one. Yeah, that's it. It's lazy evaluated. It's going to give you an iterator that has items of that type, and you would then do this. Some would be two as well. Okay, so you have map and filter. So I think, and then there's now the filter map, which would only return values, which has to return uh, an option. It gives you, it only, so it filter map would map, but also filter values where the option has only the sum type. So basically, if we have this here, um, and then let's say we wanted to, okay, so what we can do here would be that, okay, no, it's not even map, it's actually dot filter map. Yeah, dot filter map, and then we have each value. We can say return me okay. No, not okay, it's as a result. But instead we say sum I, that would be fine, and that would be everything. Yeah. So it would give us the next value here would be sum one, right? Yeah, sum one. Okay, that's fine. But if we had something like what we had before, where we had a wait, no, where we had, let's say we had, yeah, exactly. Let's say we had tofu here, and we had um broth here, for example, and this is a vector of, yeah, of just a vector of string. Okay, no, wait, hold on. Let's say everything had a, let's say what there was a vector that had string reference to string slices, yeah, like so. And then we we wanted to, yeah, to do a filter map, yeah, and we want to take each item of this filter map and take each item here, yeah, and we want to try to do a parse int, yeah, so uh parse to int, I mean, I'm still speaking in Java terms, yeah. So we do like so. We try to parse this into integer values, and this is again is filter map. So this is a closure. Perform this operation. This will give us a result, and then we, of course, we know that it has to be an option. So it has to take an option. So that okay would try to convert a result type to an option. Yeah, and that's it. Yeah. So this would give us, so yeah, exactly. So this would convert, this would give us, this would filter, it would do a math and filter at the same time and give us values, I mean like options that only have sum of I32 types. So basically it will only be sum five that would be in our values. So it will be sum five, exactly. So it's sum five. All right, so I think filter map filter itself, they're okay. We got them working. I mean, that's clear. We can, I mean, so this program here, this thing we had before, ignoring the field items. I think now we see clearly how to ignore the field items. I think that was, wait, hold on, that was here. Yeah, that was here. So basically, I can get rid of this, not needed anymore. Get rid of this and get rid of this. Yeah. So come back here. So we were doing the string values into iter that's giving us an iterator, which we can, yeah. And then we do a map. Yeah. Okay, we're just mapping here actually. And then we're printing everything that we got. Yeah. And I think it was about ignoring the failed items with filter map. So if we wanted to change this and ignore the failed items, we would do a wait, I'm curious. Okay, just hang on a second. I'm curious. So let's say we already did a map. We can do filter. All right, we can just do filter immediately. All right. So yeah. So basically we can do we already have a map. So this is already, oh no, wait, hold on. It would, yeah, exactly, because the result here is a vector that has result of I32 or passing error, right? Now we can filter, not filter map, filter. Why do you think I want the map already? So I can do a filter and I can give it a closure and say, by the way, this I can also use A because it's in the same scope. It's in the same I mean it's just the lifetime is just here, right? So I can do a filter and say and give us a predicate to say um wait, I can say it's okay. It's okay is going to be true. If it's okay, then that would give me only it should give me only the oh wait. Yeah, exactly. It should give me vector that has only results with I32, right? That should work. Yeah, it's so that's the predicate where field type the only the ones that have is okay. So what would result be here? Yep, that's correct. So I can do a filter, sorry, a map and a filter, and then I get only the values where result is okay. So, but then we can also do a filter map, not needing to do it twice like so, and then do a dot filter map and say take each item and um give it a closure, right? So say the same thing we're doing before, um, parse to the type we want, and this is the result type, and say okay, and that's it. Value is the same. Result. Hmm. Okay, this is slightly different because what we had before, we had a result. I mean, it was an okay result, but here what we have is a vector that has that type. Okay. Yeah, because oh yeah, that's true. Because so yeah, what we had before on this, yeah, slightly different. If we wanted to get that, we have to get out the value from the result, from the option. It was no, it was a result. Yeah, it was okay. It was okay 98 we had before. It was okay 98, so we'd have to either do a short circuit, yeah, or to get it. Okay, so that's fine. I think we we got it. So this is what they were trying to do here, and we did it, and also understood it right from the standard library, which is cool. Yeah. So now they say collect the failed items with map error and filter map. So map error calls a function. Map error calls a function with the error. So by adding map error calls a function with the error. So by adding that to the previous filter map solution, we can save them off to the side while iterating. Nice. And so you do a filter map and you are only interested in the values that are okay or that are some, right? That are present there because yeah, that gives you an option. So you only return the ones, you only want the ones that are that have some value. But what about the errors, right? So you want to save them to the side or do something while you're iterating, okay? And you can use map error for this. Yeah, because map error is to take uh the error to a type that you want. Yeah, that's it. So you do a map and then you do a filter map, take each item and you do map error. Oh yeah, because yeah, but you simply do a parse here. Some would fail from oh wait, yeah, because it's um lazy evaluated, yeah. So and then the chain, you're training this operation, so to say the result that comes because this is actually yeah the cool thing about this is that this doesn't panic because it returns you a result type. So the error is in the result, which is here now. So you have each item and then you do map error and then you have the error and then you push the errors to another vector that you declared here and you want okay on this okay. And so you do errors dot push and map error. What does map error return? I guess map error would return you a. I guess map error would return you in this case a. If you're returning okay, then it returns your result. Yeah, I guess map error returns your result. So we can check that in the iterator. We can go to map error. Wait, map. Wait, that is on the iterator. Yeah, that's on the iterator. So. Oh no, it's on result. It's a trait. I believe it's a trait on result. So we need to go to the result type. Come on, get result in and there will be a trait. Okay, it's actually not a trait. It's actually a method. Map error. So it's a generic over it's a generic function over f to o over f and o. Yeah, and then it takes a closure which is an which is a type here. This is an O, where O goes from E to F as an arrow from one type to the type here. What is that one here now? Um, Map arrow to that type. So it maps a result. It so it maps a result TE to a result TF. Okay, that's simpler. It's simpler. Like you just it leaves the of yeah, of course that's what map error does. It ignores the okay variant of the result and only transforms the error from one to another, one type another, by applying a function to the contained error, leaving the okay untouched. Exactly. That's what it should do. So you can okay, yeah, it transforms actually the full thing. It's just a map of error, just like what map would do. That's it. Map would map from T to F. So basically, if I say map, yeah, map goes from CE to UE. That's it. That's all it does. It just transforms from uh, one result type to another result type, leaving the error untouched. Exactly, leaving the error untouched. While map error will simply map from TE to TF, leaving the OK untouched. Right? That is it. Simple. So when you do like this and you do a map error, um, stringify, um, yeah, it's doing this on this function x to that. Yeah, okay, that's it. Yeah, yeah. So it's a function. It goes from this to that, right? So it's like it goes from from this to wait. The other function stringify that takes a u32 and then um gives you a string. Yeah, returns you a string, and then you're saying that the result of that. Oh no, sorry. This is stringify, and then this is the result here. This is yeah, you declare binding x says a result that is OK2, and then you call this function x.map error, which is x now. When you do a transform on that one, you're saying that the result would be OK2. So it goes from a result of type U32 and U32 um, map error to a result of type U32 and an error type and it would leave the OK untouched, and the error variant would be another type. But what does this function can use to pass through a successful result by handling errors? But what happens? What about, so you're saying the result is an OK2. Okay, this is because there's no error here. What is this? This is the function that you do. It doesn't. Uh, let's see this. This one says it's the result of U32 and U32, and then you initialize that to an error of 13. Okay, yeah. Um, okay, error of 13, and then you do a map error, simplify, and then okay, I see. So it does the transformation from 13 to this, and this is what will be in the error. Yeah, yeah. So depend on what you. Okay, okay, okay. That makes sense. We were looking at it from here, so yeah, we know what this does. Yeah, so this would push this here, and and then it would uh, yeah, exactly. So flat map has to return an option. So this has that's why you have okay here, and then you collect it. Yeah, and you have now your numbers and you have the errors. So let's try to do that here. Let's try that here. So you have the strings. Let's maybe make this to have like um, another value here, and this is strings. Um, so what we want to do is that we process this, and at the end of the day, we have the errors and we have the numbers, right? So that's what we want to do. So we say we can say let errors be a vector of and I think we need to uh we need to type annotation. Wait, I want to push the vector, right? So it's immutable first of all, and what do you mean? So you need the type already. No, I just want a vector that I don't want the you cannot infer. Can I do what if I try to what if I, no wait hold on. What if I um oh wait expected value found struct vec um wait I just need to create a vector that I want to push things to. So let's create a new vector. That's all we need to do, right? So why is that? Um, I don't want to give it a type because I don't know. Okay, well, it would be the error would be a parsing error, yes, but uh, wait, what did they have? What did they? Yeah, they simply said it's a mutable reference and then it's empty. So why are we not able to do this? I mean, what was I doing differently? Okay, I was trying to use the okay. We're using the macro. That's what they were using here. But it still says it needs type annotations. Is that not exactly what we have here? So yes, it is. Hmm. Why is it different? Type annotations needed for vec. Maybe is this? Oh yeah, yeah. What we were doing before was correct. I think it's probably because we haven't. So it doesn't know the type yet because we haven't put anything to it. It gets the type. It gets the first type. The when we have one value. The moment we have one item put into this now, it would know the type. Okay, that's what I was complaining about. But we can okay, let's write that first. So basically what we're doing is what we want to do is we do a we can do a map. So we want to have our numbers, and we want to have, so this can be numbers, yeah, and so we have numbers, and we want to have errors somewhere else when we collect them. So what we can do, let's think about it. What we can do is we trade over this, we do a filter map. Um, I mean, this is already numbers is currently or is already a vector of I32 types, which is fine for us like this because we're in the filter map. How do we get the errors out of it? Because we already, yeah, because with this mm, yeah, with this we already are at this point we are losing the errors because we only have the okay variance here, right? So we need to have a map because map would still leave us with a result. So if we do a map and say each item here and do a dot, yeah, we'll pass it again, right? So like when we pass this, we're gonna have a result, and we're gonna have a result. Yeah, it's gonna give us a result type. Okay, error variant. Then this we don't need this again anyway. So this is currently a result. I mean, it's lazy evaluator anyway. It's a result. I think we can do a. Can we do a filter map afterward? No, wait. We need to use first of all. We know that so map transforms. This returns a result. I mean, this closure here returns a result for us. So we know that map already returns for us a result of I32 and parsing error. Yes. So now we need a way to map the errors and leave the results untouched. Yeah. So why can't we do, um, or maybe what we need is, uh, but then if we do it, if we map this, if we do a map error, it will give us results of, it will simply get the error into another type, but we need it as a side effect. So we can, yeah, we need a side effect. So we can simply, why didn't we just use a flat map straight away, right? Because with a flat map, I mean, sorry, not flat. Yeah, exactly. It's flat map in other languages. Yeah, because with a no, not flat map. Sorry, filter map. Yeah, with a filter map, we already okay. We would have a closure. Um, yeah, what we needed is the filter map. Actually, I think we should get that back. We need this. Um, oh, it is broken here. I think. Oh yeah, because we have this one still. Yeah. Okay. So with this, with this filter map, we can do a, why can't we do a map error? Because that's going to happen by side effect, yeah? So we need a closure that will do a, maybe we can do this. So first of all, this is a, so we already have the value we want. We just need to be able to process the errors. So how would we do that? Or we need to get access to each of the errors. Um, I mean, if we process the errors, then how do we get our result? I think that's exactly what we had from. Yeah, wait, hold on. I think I was right. I was right in my thinking before that we should do a map. Yes, I was right in that. And then we do a path. Um, I think I was right in that in that because here at this point we have a result. At this point we have a result of this and that, and we can then do a map error. Yeah. So why not? Um, because it would exactly. Why can't we do a? What if we do a map error here? Oh wait, this already gives us. But this gives us a, yeah, because this gives us a result. Yeah. So this gives us a parse will give us a result already. So we can so the result of I mean the so the result that comes out of here is a result of, so parse gives us the result iterate to an error. We can map the error simply to that type, right? So we can do we can get a error, which is a passing error now, and we can say error dot, what is the, how do we, that's a vector, right? So we can push to the vector and say the error goes there, and we will still have a result of, hmm, okay, yeah, okay, exactly. So it's a unit type. It's a unit type because we did it by side effect. We didn't transform the error, so we return a unit type, which makes sense. And now we can, so we have our vector of results. We can now so yeah, exactly. So it's now we can now convert this to we can convert this now to an option. Yep. We can now convert this to an option by doing a filter map. Either we just do a filter or we do it. In fact, I'm going to do a filter. I'm going to take a predicate here. And I'm going to say where a dot is okay. Um, that's the thing. So observe the difference here. Look at this. Look how we have numbers as now. Numbers is a vector that has result of I32 type, which is fine, which is fine. Um, yeah, exactly. Wait, hold on. What if I did? Can I do this? No, you can't, right? Okay. So observe that numbers is a vector that has as a result of I32 type now. But if we choose to not use a filter, because filter again would give you a result, yeah. Wait, hold on. Filter, this is results. We need to be looking at iterator, iterator trait, and look at filter now. Filter gives you a filter. Filter map gives you a filter map. Okay. So filter map because like observe the difference here. So I'm gonna this is gonna vector result of I32. I'm gonna change this to a let's change this now because look the value is gonna be inside. It's gonna be okay of I know of the it's gonna be okay. You're gonna have a result that has okay 98 and okay 150. Show you. Let's do it. Look at it. You have okay 98 and okay 150 here. That's what you have. But the moment we say we don't want this in the but we instead want dot filter map and say yep because it's a function it I mean okay gives us the okay variant here. See the value in okay, right? So it converts the result, but wait, hold on, it converts the results to an option, but yeah, but then hmm, yeah, it acts on it and gives you the value that is there. So you no longer have it as have it on the okay. Observe the difference. You have a result that has okay values, but observe that when you do this now, you're gonna have just the values. So it basically unboxes it. So filter map would unbox it, while filter would not. So that's cool. And then we also have our errors, by the way. So we can print the errors now and say errors is just a vector, so we can print it. Um, yeah. So we have like parsing error. I mean, they're both parsing errors anyway. So okay, so that's fine. We that's fine. We wait, hold on. Now I'm getting uh okay. I don't want to push it, but I mean, there's no use of the errors without correlation to the values that cause the errors. Yeah. So what I would want actually is to push not just the error, but I want to push. I want to have a hash map. Yeah, of the of the value and the error. Right. So anyway, let's we can do that later on. I mean, I'm having ideas, but so there's the other parts, other things, but I think I'll take care of. Let's do that later, right? So this was I don't know, was it 1 hour? I think. So maybe I continue later today. I don't know. Maybe I continue, but normally I mean I would normally stream later today. Um, on Twitch normally, yeah. I decided to try it on YouTube today and see how that goes. I will check and see how the how the video worked. Okay. All right then. See you. I think I will drop my Twitch handle somewhere so that maybe on this video itself. So yeah. All right. I don't know if I will continue on YouTube. Depends on what I can. I'll just observe and see. Right. Ciao. Until later. Yeah.